Hey everybody, it's Wednesday, time for Wisdom Wednesday. Thought I would circle back around and do a little bit more information, provide a little bit more information on thyroid hormone. I've had quite a few patients coming in, and oftentimes they see a primary care physician who is just checking a TSH, and oftentimes in order to optimize thyroid in folks, we need to push the levels just a bit, and so it really suppresses that TSH. And if all you're ever checking is a TSH, it looks like you might be overtreated. But when you look at your levels in the bloodstream, and I'll kind of review that a little bit, they are often continue to be low, you continue to be symptomatic, and oftentimes we need to push that thyroid level a bit beyond some of the reference ranges that we have in order to achieve optimal levels for function within a patient. So I thought I'd kind of revisit some of that information. I actually am, I guess revisiting is kind of an interesting word, because I'm reading a book now, Revisiting Hypothyroidism, and about halfway through, and it really does a lot to explain how we got here after using desiccated thyroid for years and years and years, and all of a sudden we are just going to a levothyroxine or Synthroid, and just through confirmational bias and teaching through issues with the pharmaceutical industry, we are just taught in medical school, let's just look at that TSH, and if it's in the reference range, you must be fine, even though you still may have symptoms. And as I'm reading this book, I really see how we got to the point where we are, and how perhaps the pendulum is swinging a bit, and more folks are understanding the importance of optimizing not just T4, but also T3, and hoping to get patients really to a point where they feel well and feel as though they're getting enough thyroid in order to get through their day. But a couple months ago, I think I revisited a little bit on the thyroid and talked about what it is and the differences between T4 and T3. And so I thought I'd get a little more nerdy into this so that many people can understand why we oftentimes push the thyroid. And it seems to be that even though we can look at what's happening in the periphery with the levels of hormone that we see, and the important thing to know is that only about 0.3% of the T3 is free to move in and out of the cells and to be able to exert cellular effects, and it's 0.03% of T4 that is free in the peripheral blood. So not much of it is unbound to protein, and not much of it can move in and out. So it's really hard to get over treated, so to speak, because those levels are so small. But it's that part which is unbound that can go inside the cell. Now, we can look at those levels, but we have no way of knowing what's happening inside the cell. We don't have tests really to tell us what it is. Probably one of the best tests to see if you're really getting too much thyroid is just a resting pulse. What is your resting pulse in the morning? If you are getting way too much thyroid, that can go way up. And if you're uncomfortable, then perhaps it's something that you might find is you kind of know intuitively that perhaps you're getting too much thyroid. But for the most part, if you need more thyroid, we have to push those levels a little bit more in order to get all the cellular functioning and signaling set up so that it can enter into the nucleus. It can affect what's happening inside the nucleus with the DNA and making the types of transcription RNA to create proteins that then can signal the mitochondria to create more energy, etc. There's a lot that's happening inside the cell that we just really don't know. And so if there is a lot happening inside the cell, then perhaps there are many areas within that cell that things can break down and not function as optimally as needed for each of us to have the energy that we need. And certainly fatigue is one of the most common complaints that we see within the office on a day in, day out basis. So just to get a little bit more nerdy, just talking about what it is that's happening at the cellular level. So this thyroid hormone is synthesized in the thyroid gland, usually comes out mostly as T4, must enter the cell, and within the cell, one of the iodine is removed in order to get T3. And then whatever is in the peripheral blood does send a signal back to the pituitary gland and tell us whether or not we have enough hormone or not. But oftentimes, again, we're not measuring the functionality of thyroid hormone, we're just measuring the level. And sometimes we need to sort of have supraphysiologic levels in order to achieve optimal effects. So this thyroid hormone is transported in the blood on proteins. It's released from proteins which is released that is free, can go in and out of cells, and these then enter through specific what we call transporters located on the cell membrane. And then once it's inside the cell, a lot of that T4 is then converted to the T3, and it's that T3 then that binds on to the thyroid hormone receptors at the nuclear area within the cell. And it's this area where it makes these conformational changes that allow it to specifically bind to DNA, that then allow for this hormone response, and these promoter genes and these genes that then affect protein synthesis are regulated. And there's often recruitment of different complexes within this area in order to have cofactored proteins that are important for the full effects of this thyroid hormone. So you can see there's just so many things along the way that have to come into play. And then there's a lot of downstream effects with that amount of hormone as well, and how it is responding within the cell and how it then gets transported. These little genes then are signaling to the mitochondria to produce energy, and so on and so on and so on. And therefore there's just a lot that happens outside of the context of just looking at a single level of thyroid hormone. So if, for instance, we tend to push thyroid here in our office and it suppresses that TSH, that thyroid stimulating hormone at the level of the pituitary gland, the hypopituitary axis, if you will, in the body, and you get a suppressed TSH, it really doesn't necessarily mean that you are hyperthyroid if that is the only thing that you're checking. So it's very imperative to look at not only the peripheral levels, understanding that those free levels are a very small amount of the amount of thyroid hormone that is present, but it's that free that goes in and outside of the cells. But hopefully at some point in time, we will actually be able to measure the effects of thyroid hormone within the cell. And it is that effect that is most imperative for us to have enough energy, for us to be able to think and have good cognition, to sleep well, to have normal thermoregulatory system within the body. There's so many things that the thyroid has to take care of within our body, and we know that even though it's a minor hormone, it has major effects in our day in, day out life. Hope it hasn't been too nerdy for you, but we've given you some information and helps you understand why just a TSH is not enough information in order to manage thyroid hormone. Talk to you later. Have a great week.